Assalamualaikum warahmatullahi wabarakatuh. Today we will continue our lesson in chapter 4, Reactivity of Metals. So I just prepared the new material from for you. So this one is Google site. So I just finished building the chapter 4. Okay, so we will start. Let's start. For 4.1, just for your information, I just informed to you the 4.1 which we already discussed. Just a quick revision for 4.1, variety of minerals. So a variety of minerals are found in crust that are commonly found in a rock. So what are minerals? So mineral is natural substance with a fixed chemical composition. So mineral exists in the form of two types. Number one is element, and number two is compound. So the example is for element such as gold, silver, mercury, platinum, carbon, and sulfur. So this one just and for compound, we already discussed also about compound is exists in the form of natural compound such as bauxite, hematites, galena, cassiterite, pyrite, magnesite, and calcite. Okay, so this is a picture of elements and compound of minerals. Okay, the physical and chemical characteristic of minerals. For physical, we focus on two types. Number one is hardness, and the second one is mineral colors. Okay, so the colors, so we have reddish black for hematites, malachite green, limestone white, galena gray, cassiterite black. And the hardness, we use sclerometer as a tool to measure the mineral hardness, and the scale is called Mohs. Okay, for example, calcite or limestone, scale of 3, and diamond, scale of 10. So as we all know, diamond is the hardest mineral found in our for now. Okay, so this is a YouTube how to use sclerometer. So you can click here and you can see the
Good afternoon. Welcome to the tutorial for the sclerometer. This is the sclerometer. Take it out of the box. Be careful, there's two screws inside, springs inside. To remove them, the correct screw is already installed. It's necessary to increase the tension on the screw by pulling down this sleeve all the way until the point marked 1000 to 1000, and this is 20 newtons force. So pull it down all the way, and while we're holding it, we turn the screw to tighten, and so that it can stay there. It's not doing. It doesn't like. Okay, now it's staying. In order to make the scratch resistance test, we hold it perpendicular to the glass and push down all the way until the tip goes slightly inside and the main part of the housing touches the glass. Then we release very slightly so that the housing is not touching the glass anymore, but we're still pushing down on the tip. And then like that, we move across the glass and see if any scratch Sometimes there can be a mark. If there's a mark, you should check if it's removable or not, because it can be just from the method. The correct way to test for pass or fail is to hold it to the light and see if you can see some part of the enamel that's actually been removed and scratched off. You would see some breaks and some scratches in the surface that can't be removed by rubbing. You see that this is completely passing.
Okay, for chemical properties, we have solubility in water, mineral heating effects, and reaction with acid and alkali. So number one is soluble in water. Mineral containing sodium and potassium only dissolve in water. So the effect of heating, so mineral that contain metal oxide are usually not dissolved when heated. However, if heated with carbon, pure metal and carbon dioxide gas will be produced. So mineral containing carbonate and sulfide metal are dissolved when heated. Example, calcium carbonate when heated is changed into calcium oxide and carbon dioxide. Zinc sulfide, okay, when heated will form zinc oxide and sulfur dioxide. So metal will react with acid. Okay, so minerals containing metal oxide and carbonides dissolve in acid and release carbon dioxide gas. Okay, example, calcium carbonate add with hydrochloric acid, strong acid, so it will change into calcium chloride plus carbon dioxide plus water. Okay, uses of minerals. So calcium oxide and calcium carbonate is used to neutralize acidic soil, and also calcium carbonate is used in gas furnace to remove impurities during the iron extraction. Okay, so silicon dioxide is used to make glass, and aluminum oxide is a substance on sunscreen, lipstick, and nail polish. Okay, so now we will continue on 4.2 reactivity series of metals. So for reactivity series of metals based on reaction with oxygen, so metals heated with oxygen will produce metal oxide. So different metal have different level of reaction with oxygen. For example, iron plus oxygen, okay, react with oxygen will produce iron oxide. So while magnesium with oxygen will produce magnesium oxide. Copper also produce copper oxide. In a vigorous reaction between more reactive metals such as magnesium with oxygen, a bright flame is observed. While in the less vigorous reaction between less reactive metal such as iron, okay, so the only a glow of or slow change in color is observed. Okay, there is a difference between magnesium and iron. So magnesium is more reactive than iron. So you can see the reactivity of metals towards oxygen increase. So you can see here, okay, so magnesium is more reactive compared to the ferrum. Ferrum is iron, okay, represent iron here, and magnesium is more reactive. So this is an example. Magnesium.
Here we have a ribbon of magnesium. Magnesium is a metal, has the properties of luster. You can see it's shiny, it's malleable, it's bendable, it can conduct heat and electricity. So what we're going to do is we're going to try to react this magnesium with the oxygen in the air. Need
So
a
this
little
is
activation energy to magnesiums to
experiment
react with the
to
oxygen.
observe the
There it is.
reaction of magnesium with
So oxygen is
oxygen.
reacting with the magnesium ribbon, and it's releasing a lot of light and heat energy. This is one of the brightest lights. That's
Okay, you can see it later. Okay, just go to the Google Science Form 3 Chapter 4, and this is iron burning in oxygen. So you can see the different this is iron. So different is the reaction is slower than the magnesium. Okay, just a glow. This one is produce a very bright flame. Okay, so we continue on the reactivity series of metal based on reaction with other metals. So the position of metal in the reactivity series of metals depend on the reactivity of metal when reacting with oxygen, which means the more reactive metal will remove oxygen from less reactive metal oxide when both metal is react. Okay, for example, zinc is more reactive than copper. So when a mixture of zinc and copper oxide is heated, so zinc will remove oxygen from the copper oxide, and while zinc will become zinc oxide. So this is a word equation for the process and this reaction. So zinc and copper oxide, after we heated the mixture, and then will become zinc oxide and copper. Okay. For the other example that you can see is magnesium is more reactive than zinc. But in this situation, when a mixture of zinc and magnesium oxide is heated, so the magnesium is more reactive. So there is no reaction occurs. Okay, let's see the word equation. So zinc is pure zinc. Okay, we heat it together with magnesium oxide, so there is no reaction occurs, which means magnesium is more reactive, so it will not take the oxygen from the magnesium oxide. Okay, zinc itself will not change into zinc oxide, okay, because of the magnesium is more reactive. So the position of carbon and hydrogen in reactivity series of metals. So carbon and hydrogen is non-metal. Okay, metal which are less reactive than carbon in a reactivity series of metal can be extracted from their ores through the reduction of oxide of this metal by carbon. Example, zinc oxide, okay, plus carbon, so you will extract the zinc oxide, become zinc, and produce carbon dioxide gas. Other example, lead 2 oxide, okay, react with carbon, so will produce lead and carbon dioxide gas. Okay, these two metals is less reactive. Let's see what happened to the metal that are more reactive than carbon in the metal reactivity series. Cannot be extracted from their ores. For example, aluminum oxide is more reactive than carbon, so there is no change in this process. So application of position of carbon in the reactivity series of metal for industrial use is metal extraction. Okay, so you can see here, so the position of carbon is here. So the metals that more reactive than carbon, such as aluminium, magnesium, calcium, sodium, and potassium, cannot be will not have a change to the reaction because of the position. But for zinc, iron, tin, lead, copper, we can have the extraction of metal by using this process. Okay, so this is another example, reduction of copper oxide by hydrogen later. Okay, this one is extraction of metals. You can see for hydrogen. So hydrogen is also one of the non-metals that we have. So the metal which are less reactive than hydrogen in reactivity series of metals can be extracted from their ores through the reduction of oxide of this metal by hydrogen. So hydrogen here, so zinc will not have reaction towards hydrogen. So we have iron, tin, lead, copper. Okay, this iron. So iron 3 oxide react with hydrogen will produce iron and water, and lead 2 oxide plus hydrogen will have leads and water. So the metal that more reactive than hydrogen cannot be extracted from their ores. Example, aluminium, aluminium oxide cannot. There is no change. Same with the carbon. So you need to understand the position of reactivity series of metals. So it's easy to understand the concept of hydrogen and carbon reaction towards metals. So this one is next one is 4.3. Just a simple extraction of metal from their ores. So extraction of metals is a process to obtain metals from their ores. The metal higher than carbon in the reactivity series of metal. The extraction of metal from its metallic compound is through electrolysis. Why? Because as I mentioned earlier in 4.2, so we cannot extract using carbon for higher metals than carbon in reactivity series of metals. So they can be extracted by using the electrolysis process. Okay, for metals lower than carbon in the reactivity series of metal, the extraction of metal is through the reduction of its oxide with carbon. So these metals such as zinc, iron, tin, and lead. So we use metal extraction using the reduction of its oxide with carbon. For copper and mercury metals, extraction is done through direct heating of a metallic compound. Okay, so iron extraction, process of iron extraction is carried out by a blast furnace. Okay, blast furnace is a mixture of concrete iron, ores or iron oxide, coke and limestone is added into a blast furnace through the top. A very hot blast of air is pumped into the furnace through the bottom. So the reaction that occurs in the furnace at high temperature is production of iron. So iron 3 oxide being heated in a high temperature, so produce iron and carbon dioxide. So, and also carbon monoxide is produced during this process, and iron 3 oxide react with carbon monoxide and produce more iron, and iron 2 oxide react with carbon and create more iron and carbon dioxide. So the other than production of iron, so we in this process they also create a slag. Slag is a combination of calcium carbonate, calcium oxide, and also a combination of silicon dioxide. Also a lot of calcium silicate. Okay, at high temperature of furnace, iron that will produce will melt. The molten iron that have solidified is known as a cast iron, and slag that is produced will melt also. From time to time, this molten slag is tapped off and used to make the base of building or roads. Okay, so this is a YouTube show the European biggest blast furnace in
This is the new hot air nozzle for stoking the fire.
Europe, I think.
Some 1,000 construction workers are overhauling this blast furnace during its turnaround. Production engineer Rainer Klock is hoping it'll go back on stream in a few
Okay,
days.
don't forget
Every day
to
counts as
subscribe
revamping
to
it
channel
costs 200 million euros.
by clicking this
We're upgrading
sign.
everything around the furnace too. During normal operations, you can't get in here to do repair work.
in Europe. So in
The
this one
blast
is
furnace was in continual operation for 20
German.
years. This turnaround was a scheduled event. Only Rainer Klock and his colleague
Cubic
so you
meters.
can see the
The
size
structure's
of
inside diameter is
blast
14 meters,
furnace.
90.
Okay,
And that translates into a furnace that can produce up to 12,000 tons of pig iron a day. We have to do the masonry work by hand because everything has to fit exactly. We have to keep the joint.
Water evaporates immediately, and the 100-meter-high blast pig iron, which is remelted and processed into steel. As production
Filling an entire hour.
tapping from the blast furnace involves molten pig iron at a temperature of 1,470 degrees Celsius.
so you can see this one is melt iron.
If the quality of the pig iron is up to standard, Rainer Klock has the furnace continue operating as it is. 12,000 workers produce more steel at this site than anywhere else in Europe.
The dimensions here are immense, but it all runs efficiently anyway. The most fascinating part? Well, a normal working day is pretty fascinating. Here in production, no one day is quite like another. Tapping the iron is one of the most fascinating sights. I remember watching it when I came here with my grandfather. He worked here, and now I work here.
Rainer Klock studied metallurgy. Like many of his colleagues in the control room, he comes from a metal worker family.
We're in constant contact with the staff outside. They let us know if there are any problems.
Okay, so we continue mining issues in Malaysia. So we have some issues: the air pollution due to the burning of fuel, water pollution, soil erosion, sound pollution, destruction of habitat due to the construction of mines, usage of large amount of electrical energy, and also air pollution by gas released from blast furnace. So that's all for chapter 4. So I just also prepare for you the quiz for chapter 4. Okay, you can answer here, or you can click here to go to the Google form. Okay, you can answer there, or you can answer in the here also. Okay, so thank you very much for your time, and we will see again in our next class. Thank you.